Hello students, welcome to the class. So in the previous class, we have discussed some set of questions based on this topic equilibrium. Moving to the next set of the questions. Here we have the 96th question. The molar solubility of calcium fluoride KSP is 5.3 into 10 raised to minus 11 in 0.1 molar solution of sodium fluoride. Will be how much? So calcium fluoride, they have given solubility product KSP value. Yes. So if you look here, calcium fluoride, how it dissociates? CaF2, it dissociates to give me Ca plus 2 ions plus F minus ions. To balance it, I will write 2F minus ions. Okay. So if S is the solubility of calcium, 2S will be the solubility of fluorine. Yes. And in sodium fluoride, they have said. So NaF, it dissociates how? It gives me Na plus ions plus F minus ions. Correct? F minus ions I get. So here they have said what? In 0.1 molar NaF. So this is 0.1. This is also 0.1 because and 0.1, if this is so much, NaF being a strong salt, it will dissociate. Yes, completely. So here I need not show this also. Correct? I have to be very particular. So this is how we show it. Correct. Okay. So what is the concentration of Ca plus 2 ions? It is yes. Solubility. What is the concentration of F minus ions? It is 2S plus 0.1. Correct. 2S plus 0.1, which nearly comes to 0.1 molar. Yes. KSP is equal to, how do we write? Molar concentration of Ca plus 2 into molar concentration of F minus raised to 2. So KSP is given how much? 5.3 into 10 raised to minus 11 is equal to, calcium concentration is kept as S and F minus is how much? 0.1 the whole square. Correct? 0.1 the whole square. So here S will be equal to what? S will be equal to 5.3 into 10 raised to minus 11 divided by 0.1 into 0.1. So 0.1 into 0.1 is what? 10 raised to minus 2. Take it to the numerator, it becomes 10 raised to plus 2. So it is 5.3 into 10 raised to minus 9 moles per liter. Or you can say 5.3 into 10 raised to minus 9 molarity. So molar solubility is how much? 5.3 into 10 raised to minus 9. Correct? So which is the correct option? The correct option is 5.3 to 10 raised to minus 9 moles per liter. Option C is the correct option. The solubility of barium sulfate in water is 2.42 into 10 raised to minus 3 grams per liter. At 298 Kelvin, the value of its solubility product will be. Yes, simply see how it dissociates first, as we have seen here. So solubility of barium sulfate. Solubility of barium sulfate, BaSO4. Solubility, how do we calculate? It is 2.42 into 10 raised to minus 3 grams per liter. It is, I have to convert it to moles. So what is the molar mass? Given mass upon molar mass converts into moles. So molar mass comes out to 233. It becomes moles per liter. And that comes to around, solve it out, you will get 1.04 into 10 raised to minus 5 moles per liter. This is the solubility. Now, how does barium sulfate, BaSO4, ionizes? It ionizes completely. It ionizes completely in solution. Yes. So how do we show ionization? Barium sulfate. Yes, it ionizes completely and gives me Ba plus 2 plus SO4 minus 2. Yes. So if I say S is the solubility, for SO4 minus 2 also it is S. So KSP is equal to what? Concentration of Ba plus 2 into molar concentration of SO4 minus 2 is the KSP value. And I know that what is S? S is equal to 1.04 into 10 raised to minus 5 into same. Both have same S value. Therefore, it is square I will do. So solve it out, you will get the answer. 1.04 into 1.04 is 1.08 into 10 raised to minus 5 into 2 is minus 10 moles square per liter square. Yes. So this is the KSP value. So which is the correct option? You have to first convert it from grams to moles. So the correct option is option A, 1.08 into 10 raised to minus 10 moles square per liter square. Yes, molar mass is also given. Next question, concentration of Ag plus ions in the saturated solution of Ag2C2O4 is 2.2 into 10 raised to minus 4 moles per liter. Solubility product of Ag2C2O4 is, so Ag2C2O4, silver chromate it is. Yes, how silver oxalate, sorry. So solubility, let me say solubility of Ag2C2O4, yes, BS, S moles per liter. Okay, so Ag2C2O4, it will dissociate how? It will, so this is S solubility. It will dissociate to give me Ag plus, there are 2 moles, plus C2O4 minus 2, and there is only one more. So this is yes, 2 coefficients, so it is 2s, and this is yes, correct. How do you write solubility product? KSP is equal to molar concentration of Ag plus raised to 2 into molar concentration of C2O4 minus 2 raised to 1, because there is only one coefficient. So Ag is how much? 2s, the raised to 2, and this is yes. Therefore, KSP is equal to what? 4s square into s is 4s cube. Yes, and they have given us value of solubility product, concentration is being given, right? So let us say KSP is equal to what? 4 into 1.1 into 10 raised to minus 4. It is given 2.2 into 10 raised to minus 4. I will take it as 1.1 into 10 raised to minus 4. The reason is Ag plus is what? Ag plus is equal to 2s. So 2s is equal to what? See here. You can see here Ag plus is equal to what? It is 2s. So 2s is equal to what? 2.2 into 10 raised to minus 4. Then what is s? S will be 2.2 into 10 raised to minus 4 divided by 2. So it comes out to 1.1. So I'll keep it, take here 1.1. And there is whole cube. When we solve it out, we'll get the answer 5.3 into 10 raised to minus 12. 5.3 into 10 raised to minus 12. So which is the correct option? Let us see here. The correct option is option 5.3 into 10 raised to minus 12. It is option C, which is the correct answer. Yes. Next question. The solubility of AgCl solid with solubility product 1.6 into 10 raised to minus 10 in 0.1 molar NaCl solution would be. So solubility of AgCl. How does AgCl dissociate? Yes. So here AgCl, it is in aqueous state. If you put it, dissociates to give me Ag plus Cl minus. Okay. So here Ag solubility product, if I take it as S, then I'll get Ag plus also S moles. And they have said 0.1 molar solution of NaCl. Therefore, what will be Cl? You know that NaCl dissociates how? It will dissociate completely to give me Na plus Cl minus. So if this is 0.1, this also will be 0.1 and this also will be 0.1, correct? So here Cl is what? S. So what will be total moles of AgCl? Sorry, Cl minus. Total moles of Cl minus will be S plus 0.1, correct? Total moles. So find the KSP. KSP is equal to molar concentration of Ag plus ions into molar concentration of Cl minus ions. What is KSP given? 1.6 into 10 raised to minus 10 is equal to molar concentration of Ag plus is S. Molar concentration of Cl minus is S plus 0.1. See, solubility of AgCl is very less. Therefore, I can say when I compare this, it is very less than 0.1. Therefore, it becomes what? 0.1. Solubility is neglected. Okay. So solve for yes. it will be 1.6 into 10 raised to minus 10 divided by 0.1 is nothing but what? 10 raised to minus 1. Take it to the numerator, you get 1.6 into 10 raised to plus 1. So minus 10 plus 1 becomes what? Minus 9 molarity. So what is the value of S? The value of S is 1.6 into 10 raised to minus 9 molarity. 1.6 into 10 raised to minus 9 molarity. Is that right? Yes, so correct option is what? Option B, that is 1.6 into 10 raised to minus 9 molarity. Yes, 100th question. My and Ny3, two nearly insoluble salts, have the same Ksp value of 6.2 into 10 raised to minus 13 at room temperature. Which statement would be true in regard to My and Ny3? So the statements given are salts My and Ny3 are more soluble in 0.5 molar Ky than in pure water. The addition of salt of Ky to a solution of My and Ny3 will have no effect on their solubilities. Molar solubilities of My and Ny3 in water are identical. Molar solubilities of My in water is less than that in Ny3. Okay, so let us see, let us solve it out and see what is the explanation we can give here. For salt, say My, yes, let me say the Ksp is S1 square. Okay, so therefore I can write here S1 is equal to what? Root of Ksp. Okay, so that is what? Root of 6.2 into 10 raised to minus 13. That is equal to 7.87 into 10 raised to minus 7 moles per liter you will get, or you can say molarity. Similarly, for salt, Ny3, how many are there? 4 atoms are there. I can write Ksp is equal to S2 into, since there are 3 into Y2 the whole cube, because there are. So solve it out, what we get? We get 27 S2 raised to 4. Yes. Okay, instead of why we don't write here, what we write here, we write it as S. So it is yes, and here it is 2. Solubility. Okay, therefore solubility of S2 will be what? Fourth root of 6.2 into 10 raised to minus 13 divided by how much? 27. When you solve it out, you will get the answer 3.89 into 10 raised to minus 4 moles per liter. So observe this answer. Solubility of S1, that is for molecule My, and solubility of S2, that is molecule Ny3. Yes, what information do we get here? If you look here, the molar solubility, what I can say, molar solubility of My in water is less. Yes or no? It is less than that of Ny3. Yes, it is less than that of Ny3. So see here, value. Don't look at this value, look at here. So it is less than that of Ny3. So which is our correct option, which holds true? It is option D. Molar solubility of My in water is less than that of Ny3. So option D is the correct option, right? Next question. The Ksp of Ag2CrO4, silver chromate, AgCl, silver chloride, AgBr, silver bromide, and AgI, silver iodide are respectively 1.1 into 10 raised to minus 12, 1.8 into 10 raised to minus 10, and 5.0 into 10 raised to minus 13, and 8.3 into 10 raised to minus 17. Which one of the following salts will precipitate last if AgNO3 solution is added to the solution containing equal moles of sodium chloride, sodium bromide, sodium iodide, and sodium chromate? Okay, so how to understand this question? Which one will precipitate out last? So let us take example. Let us solve this question out. So let us say here, I'll make a distinction. Okay, here we will consider our salt, right? And here we will consider the KSP value. And here okay, and here we will take up, so I'll take a distinction like this. Okay, okay, fine. So this is what? This is our salt. Here we'll write salt. Here we will see KSP, and here that is solubility product. And here we'll see solubility. Then we will compare and tell the answer. Okay. So which is the salt? First one, Ag2CrO4. Correct. So Ag2CrO4, they have given how much? 1.1 into 10 raised to minus 12. 1.1 into 10 raised to minus 12. The salt is of type A2B4. Therefore, it is 4S cube. Okay. Then S will be equal to what? Cube root of KSP upon 4. Correct. And that value comes out to 0.65 into 10 raised to minus 4. Substitute and find the answer. This is first one. Second one is what? Silver chloride. How much is the value given? Silver chloride. It is 1.8 into 10 raised to minus 10. It is made up of two atoms. So it is of type AB. Therefore, it is S square. Solubility, there is, it differs. Therefore, S is equal to what? Root of KSP. And root of 1.8 comes out to 1.34 into 10 raised to minus 5. Third one is AgBr. This is also of the type 5 into 10 raised to minus 13. It is also of type AB. Therefore, it is S square. So, S is what? Root of KSP. And answer comes out to 0.71 into 10 raised to minus 6. Okay. And fourth one is AgI, silver iodide of type AB. 8.3 into 10 raised to minus 17. Therefore, it is also S square. S is what? Root of KSP. It comes out to 0.9 into 10 raised to minus 8. So if you see here, compare all of them, the solubility of which one? Yes, where solubility is highest. So this is 10 raised to minus 4, 10 raised to minus 5, 10 raised to minus 6, 10 raised to minus 8. So solubility is highest where? It is highest. Solubility of Ag2CrO4 is highest. It is highest, correct? Thus, it will be last precipitated. Which is highest? Where KSP solubility is highest, it will be precipitated last. Precipitated last. Yes, understood how to do it. Yes, so we have solubility and solubility product. By that, we'll understand which will precipitate at the last. So, which is the correct option? It is option B. It is option B. Next question. Using the Gibbs energy change, delta G naught is equal to plus 63.3 kilojoules for the following reaction. Ag2CO3 gives 2Ag plus CO3 minus. The KSP, that is solubility product of Ag2CO3 in water, will be. Okay. So delta G naught is given here now. Fine. So let us write. What is the value of delta G naught given? We know that delta G naught is equal to what? It is equal to minus 2.303 RT log KSP. Yes, it differs. Solubility product, therefore KSP. Delta G naught given is how much? Plus 63.3 into 10 raised to 3 I will take. Because kilojoules is given, I'll take joules. Correct? Minus 2.303 into R value is 8.314 into temperature, what they have said, at 25 degrees Celsius, 25 plus 273 is how much? 298 into log of KSP. So log of KSP, I'll keep it as it is. When you solve it out, you will get 63.3 into 10 raised to 3 is equal to minus 5705.84 log of KSP. Therefore, log of KSP will be equal to 63.3 into 10 raised to 3 divided by minus 5705.84, correct? This answer, solve it out, you will get the answer minus 11.09. So log of KSP is minus 11.09. What will be KSP? It will be anti-log of. When you take logarithm on the other side, it becomes anti-log of minus 11.09. And anti-log of minus 11.09 comes out to 8.128 into 10 raised to minus 12. This is the answer. Yes, you have to be very perfect while checking for log and anti-log. So 8.128 into 10 raised to minus 12. So which is the correct option? It is option B, 8.0 into 10 raised to minus 12. Yes. Next question. The values of KSP, that is solubility product of calcium carbonate and calcium oxalate, are 4.7 into 10 raised to minus 9 and 1.3 into 10 raised to minus 9 respectively at 25 degrees Celsius. If the mixture of these two is washed with water, what is the concentration of Ca plus 2 ions in water? See, some questions will be very beautifully framed, right? So calcium carbonate, how it dissociates? Calcium carbonate dissociates to give me Ca plus 2 plus CO3 minus 2. Yes. So if this is X, this will also be X, correct? How does calcium oxalate C2O4 dissociates? It will give me Ca plus 2 plus C2O4 minus 2. So if this is Y, this is also Y. I'm talking about solubility. Now what you do, what is calcium ions? Ca plus 2 ions. Yes, it is X plus Y. X plus Y. And X of X plus Y is how much they have said? 4.7 KSP. Yes, X of X plus Y. This is X and this is X plus Y. Yes or no? So how much they have said? They have said 4.7 into 10 raised to minus 9. Understood how this I got? So KSP is what? It is Ca plus 2 into CO3 minus 2. Okay. And Ca plus 2 total is X plus Y into X. Therefore, X of X plus Y. And its value is how much given? It is given 4.7 into 10 raised to minus 9. Okay. Then second here, Y of X plus Y. Yes, this is what, this is KSP of calcium carbonate, and second one what I am writing is KSP of calcium chromate, calcium oxalate. It is given as 1.3 into 10 raised to minus 9. Yes, let me call this equation as 1 and this equation as 2. Divide the equations. X, this is gets cancelled. Yes, so I will write it first here. X of X plus Y divided by Y of X plus Y is equal to 4.7 into 10 raised to minus 9 divided by 1.3 into 10 raised to minus 9. This gets cancelled, this gets cancelled. Therefore, X by Y is equal to what? It is equal to 4.7 divided by 1.3. Solve it out. X by Y is equal to 3.6. Or say X is equal to 3.6Y. Now put this value in equation 2. Yes. So what is equation 2? Y into 3.6y plus y is equal to 1.3 into 10 raised to minus 9. Yes. So 3.6 plus 1 is 4.6. 4.6 into y square is equal to 1.3. Therefore, on solving, we'll get the value of y equal to 1.68 into 10 raised to minus 5. I got the value of y. But they have not asked me why. They have asked me calcium total ions. So let me take this. Therefore, what will be X? X is how much? 3.6y. So 3.6 into 1.6 into 10 raised to minus 5, because it's the value of y. It will come out 6.05 into 10 raised to minus 5. Correct? So this is the value of X. Therefore, how many calcium ions are there? Concentration of calcium ions is equal to how much? X plus Y. So how much is X? 1.68 into 10 raised to minus 5. plus how much is Y? 6.05 into 10 raised to minus 5. Solve this out, you will get the answer 7.73 into 10 raised to minus 5 molarity. Got clear? Got clear with the question? Yes, very beautifully the question is being framed, right? So which is the correct option? The correct option is 7.746 into 10 raised to minus 5. Around we get, yes. So 10 raised to minus 5 is the correct answer. Next question, identify the correct order of solubility in aqueous medium. So in aqueous medium, sodium sulfide is there, copper sulfide is there, zinc sulfide is there. Sodium sulfide, it is soluble in water. The solubility product and hence solubility of zinc sulfide is larger than copper sulfide. So first comes sodium sulfide, then comes zinc sulfide, and then comes copper sulfide. So which is the correct option? First sodium sulfide, then comes zinc sulfide, and then copper. So option B is the correct option. Yes. Next one. pH of a standard solution of barium hydroxide is 12. The value of solubility product KSP of barium hydroxide is. Okay. So they have given pH. pH of barium hydroxide solution is how much? It is 12. That means what will be H plus ion concentration? It will be 10 raised to minus 12, correct? Then if H plus ion concentration is 10 raised to minus 12, what will be OH minus? It will be 10 raised to minus 14 divided by 10 raised to minus 12. That comes out to what? 10 raised to minus 2, correct? Now, how does barium hydroxide dissociate? Barium hydroxide dissociates to give Ba plus 2 plus OH minus. There are two OH minus, correct? And here this is S, this is what? 2S. So 2S is equal to how much? OH minus ion concentration. It is equal to 10 raised to minus 2. Therefore, S is equal to what? S is equal to 10 raised to minus 2 divided by 2. Find the KSP. KSP is equal to concentration of Pa plus 2 into concentration of OH minus raised to 2. So S into 2S the whole square. So what is the value of S? 10 minus 2 the divided by 2 into 10 minus 2 is the whole square. Everything becomes what? It becomes cube. Therefore, I can solve it out for, so this comes out what? 4s cube. Okay, it comes out to 4s cube. So here I'll write 4 into, correct? So solve it out, you will get 4 by 8 into 10 raised to minus 6. And the answer comes out to 5 into 10 raised to minus 7. Correct? 5 into 10 raised to minus 7. So which is the correct option? Option B is the correct option. 5 into 10 raised to minus 7. So next question. In the qualitative analysis, the metals of group 1 can be separated from other ions by precipitating them as chloride salts. A solution initially contains Ag plus and Pb plus 2 at a concentration of 0.1 molar. Aqueous HCl is added to this solution until Cl minus concentration is 0.1 molar. What will be the concentrations of Ag plus and Pb plus 2 be at equilibrium? Given KSP for AgCl is this much, 1.8 into 10 raised to minus 10. KSP for PbCl2 is 1.7 into 10 raised to minus 5. Okay, they have given two solubility products. So we'll compare the two solubility products, right? So let us see KSP of AgCl. How do we write it? We write it as concentration of Ag plus ions into concentration of Cl minus ions, correct? So Ag plus will be what? Ag plus will be KSP divided by Cl minus. So KSP is how much? 1.8 into 10 raised to minus 10 divided by 10 raised to minus 1. That's 0.1 means what? 10 raised to minus 1. That comes out to 1.8 into 10 raised to minus 9 molarity. And KSP, that is solubility product of PbCl2 is, how do we write? Pb plus 2 concentration into Cl minus concentration raised to 2. Yes. So Pb plus 2 concentration will be what? Solubility product given is 1.7 into 10 raised to minus 5 divided by, if it is Ksp, so 1.7 into 10 raised to minus 5 divided by 10 raised to minus 1, the 0.1 square. So 10 raised to minus 1. So 10 raised to minus 2. So it comes out to 1.7 into 10 raised to minus 3. Yes. So Ag plus ions is 1.8 into 10 raised to minus 9. And Pb plus 2 ions is 10 raised to 1.7 into 10 raised to minus 3. So which is the correct option? It is option, the correct option. C is the correct option, right? Next question. H2S gas, when passed through solution cations containing HCl, precipitates the cations of second group of qualitative analysis, but not those belonging to fourth group. It is because presence of HCl decreases the sulfide ion concentration. Solubility product of group 2 sulfides is more than that of group 4 sulfides. Presence of HCl increases the sulfide ion concentration. Sulfides of group 4 cations are unstable in HCl. See, when we speak about the cations of group 2, okay, the cations of group 2, they are precipitated as their sulfides. They are precipitated as their sulfides. Solubility of sulfide of group 2 radicals are very low. Solubility is very low. Okay. Therefore, even with low concentrations of S2 minus ions, the ionic product exceeds the value of their solubility product. So what I can say is the low concentration of S2 minus ions is obtained by passing H2S gas through the solution of salt in presence of dilute HCl. In presence of dilute HCl. So what it does, it suppresses the degree of ionization. So I can show you H2S, it dissociates to give me H plus, 2H plus S minus 2. Okay. So if I add HCl, what will happen? HCl is a strong acid. It will form H plus Cl minus. So here common ions are flourished, which will do what? They will suppress the degree of dissociation of H2S. Okay. So you can note here, solubility product of group 4 radicals are quite high. So it is necessary to suppress the concentration of S2 minus ions. Otherwise, the radical of group 4 will also get precipitated. Therefore, what is the correct option? Presence of HCl decreases the sulfide ion concentration. Option A is the correct option. Understood? Option A is the correct option. Next question. The solubility product of sparingly soluble salt AX2 is 3.2 into 10 raised to minus 11. It's a solubility in moles per liter. That is molarity. Okay. So KSP, how much it is given? KSP is 3.2 into 10 raised to minus 11. Okay. And they have said the molecule is of type AX2. It will dissociate to give me what? A plus 2 plus 2X minus. If this is yes, this will be 2S. Therefore, KSP is equal to concentration of A plus 2 into concentration of X minus raised to 2. So this is yes. Here it is 3.2 into 10 raised to minus 11. Yes into 2S the whole square. This is 4S square into S. It is 4S cube. 3.2 into 10 raised to minus 11. So what is S? S is equal to, solve it out, you will get the answer 2 into 4S cube. So S will be what? It will be 2 into 10 raised to minus 4. 2 into 10 raised to minus 4. Because 4 ones are 4, 3, 4 8s are 32. So it is 0.8 into 10 raised to minus 11 we get. That is 8 into 10 raised to minus 12 is equal to S cube we get. Therefore S will be what? Cube root of this. And that comes out to 2 into 10 raised to minus 4. So the correct option is, it is 2 into 10 raised to minus 4. Yes, it is option C. The solubility product of AgI at 25 degrees Celsius is so much, 1.0 into 10 raised to minus 16 moles square per liter square. Solubility of AgI is 10 raised to minus 4 normality solution of Ki at 25 degrees Celsius is approximately. Okay, so take AgI. So I have AgI dissociating to give Ag plus I minus, and Ki dissociates to give K plus I minus. So they have said this is 10 raised to minus 4. So this also will be 10 raised to minus 4. AgI, so it is 10 raised to minus 4. For Ki, one normality is equal to one molarity. Okay. Therefore, I minus concentration will be equal to what? It will be, this is S. So it will be S plus 10 raised to minus 4. Correct? 10 raised to minus 4. KSP equal to molar concentration of Ag plus into molar concentration of I minus. Ag plus is S. This is S plus 10 raised to minus 4. Correct? And KSP is 1 into 10 raised to minus 16. Is that right? So solve it out. 1 into 10 raised to minus 16 is equal to S into S plus 10 raised to minus 4 is S square plus 10 raised to minus 4 S. This you solve it out, you will get 1 into 10 raised to minus 16 is equal to 10 raised to minus 4 S. Therefore, S will be equal to what? 10 raised to minus 16 divided by 10 raised to minus 4. Answer comes out to 10 raised to minus 12 moles per liter. Moles per liter. Yes. So S square being very much less than 10 raised to minus 4 S, it is neglected. So we'll take it as 10 raised to 4 minus 4 S. So what is the correct option? The correct option is option B, 1.0 into 10 raised to minus 12. Solubility of MX2 type of electrolytes is 0.5 into 10 raised to minus 4. Find out the solubility product. Okay. So here MX2 dissociates how? It dissociates to give M plus 2 plus X minus 2 molars. So it is S, this is 2S. So KSP is what? Concentration M plus 2 into X minus raised to 2. S into 2S square. So 4S cube. So 4 into, what is S value given? This is 0.5. So I'll get 4 into 0.5 into 10 raised to minus 4, the whole cube. Answer comes out to 5 into 10 raised to minus 13. So it comes minus 12, 0.5. So 5 into 10 raised to minus 13. So correct option is what? Option D. 5 into 10 raised to minus. Yes. Next, solubility of M2S salt is so much. Find out the solubility product. Same thing. M2S they have said. So let us take here. So M2S dissociates how? It dissociates to give me M plus, so 2M plus S minus 2. Correct? So if this is 2S, this is yes. So solubility product KSP is equal to what? Molar concentration raised to 2 into S minus 2 raised to 1. So 2S the whole square into S, 4S cube. Correct? So 4 into 3.5 into 10 raised to minus 6 the whole cube. 6 3s are 18. So it comes out to 1.7 into 10 raised to minus 16. So 1.7 into 10 raised to minus 16 is the correct option. Is that right? Okay. The solubility of a saturated solution of calcium fluoride is 2 into 10 raised to minus 4 per liter. Its a solubility product is. Again, same question. Calcium fluoride, how it dissociates? Ca plus 2 plus 2F minus. If this is S, this is 2S. Correct? Therefore, KSP will be what? 4S cube and 4 into, what is S? 2 into 10 raised to minus 4, the whole cube. So 4 2s are 8, 8 into, okay, 2 2s are 4, 4 2s are 8, 8 2s are 8 4s are 32. So it is 32 into 10 raised to minus 12. Correct? 32 into 10 raised to minus 12. Is that right? Okay. The solubility product of CUS, Ag2S, HGS are 10 raised to minus 31, 10 raised to minus 44, 10 raised to minus 54 respectively. Solubilities of these sulfides are in the order. Greater the solubility product, greater is its solubility. So which is highest? Greater the solubility product, greater is its solubility. So this is greater. What is this? CUS. So CUS comes first, then comes 10 raised to minus 44, that is Ag2S, then comes HGS. So which holds this answer? It is option B. So option B is what? It is the correct option. Is that right? Okay. The solubility of AgCl will be minimum in. See, where there are greater number of Cl minus ions. So if you see here, there are greater number of Cl minus ions in calcium chloride. NaCl there is one. Here there are two Cl minus ions. Compared to all others, pure water it does not have. This also does not have. This has only one. So solubility of AgCl will be minimum in 0.01 calcium chloride because of common ion effect. So it will flourish common ions which will suppress the degree of dissociation of AgCl. Therefore, it is minimum in option A. Next question, which one of the following is most stable? Bi2S3, bismuth sulfide, Ksp is 1 into 10 raised to minus 70. Silver sulfide, Ksp is 6 into 10 raised to minus 51. Copper sulfide, Ksp is 8 into 10 raised to minus 37. And D is MnS, Ksp is 7 into 10 raised to minus 16. Higher the value of solubility product, greater is its solubility. We have seen this. Correct? Higher the value of solubility product, greater is its solubility. So which is having higher value? Minus 70, minus 51, minus, this is having higher value. So it is for MnS. So next question. If 1 mole of I2 is introduced into 1 liter flask at 1000 Kelvin at equilibrium, Kc given is 10 raised to minus 6, which is correct? Okay, let us see here. So what they have done, I2 is in equilibrium with 2I minus ions, correct? So here they have said 1 mole is introduced. So if X is the degree of dissociation, how much will be remaining at equilibrium? It will be 1 minus X, and this will be what? 2X, correct? So Kc will be equal to what? It is I minus raised to 2 into I2. Is that right? So it is 2x square, the whole square, divided by 1 minus x. Solve it out, you will get 10 raised to minus 6. 10 raised to minus 6. Yes. So which is the correct option here? It is 10 raised to minus 6 means what? Okay. So 10 raised to minus 6 means 1 minus x is more than 2x. So 1 minus x is what? Yes, we have seen here. 1 minus x, this 10 raised to minus 6 means 1 minus x is more than 2x. And what is 1 minus x? Concentration of I2 is more than concentration of I minus. Correct? So concentration of I2 is more than concentration of I minus. So which is the correct option? It is option A. I2 concentration is more than I minus concentration. Second question, in the reaction, A plus 2B gives 2C. 2 moles of A, 3 moles of B and 2 moles of C are placed in 2 liter flask. And the equilibrium concentration of C is 0.5 moles per liter. The equilibrium constant for the reaction is. Okay, let us write the reaction. So here A plus 2B gives 2C. Okay, so initially, if I speak, initially there are initial moles in 2 liters. Okay, so there are 2 here. Here there are 2 into, so here there are 3 moles. They have given it. A is 2, B is 3 and C is 2. At equilibrium, moles in 2 liters will be how much? Moles in 2 liters will be 2.5 here, correct? Then here it will be 4 and here it is 1. Molar concentration, moles in 2 liters will be 1.25. Yes, according to our question, 2 and 0.5. Understanding? 0.5. So solve it out. Kc will be what? It is concentration of C raised to 2 divided by concentration of A into concentration of B raised to 2. So C square 0.5 the whole square divided by 1.25 into to the whole square, correct? When you solve it out, you will get the answer 0.05. What is this? This is equilibrium constant. So equilibrium constant is how much? 0.05. Option C is the correct option. Next question. Kc for the reaction N2 plus O2 gives 2NO. At 300 Kelvin is 4.0 into 10 raised to minus 6. Kp for the above reaction will be, R is given as 2 calories per mole. We know the relationship between Kp and Kc. What is the relationship? The relationship is Kp is equal to Kc RT delta N. Yes. And here for the reaction, what they have given, delta N is what? Delta N is 0. If delta N is 0, Kp is equal to Kc. Correct? Kp is equal to what? It is equal to Kc. So let us see which is the correct option. So how much is Kp? 4.0 to 10 raised to minus 6. It is equal to Kc. Therefore, see 2 minus 2 is 0. Delta N is 0 means what? Kp will be equal to Kc. Understanding? Next question. Delta G naught for the reaction X plus Y gives Z is minus 4.606 kilocalories. The equilibrium constant for the reaction at 227 degrees Celsius. We know the relationship between delta G naught and equilibrium constant. What is the relationship? The relationship is delta G naught is equal to minus 2.303 RT ln K. That is Kc. Okay. So delta G naught is minus 4.606 kilo. They have said 10 raised to 3 I will take is equal to minus 2.303 into R is given as 2 kilocalories into 500 temperature into log Kc. Correct? So solve this out, you will get Kc will be equal to 100. When you solve it out, you will get the answer Kc is equal to what? It is equal to 100. So which is the correct option here? Kc is equal to 100. Yes. Next question. The equilibrium constant for the reaction SO3 gives SO2 plus half O2 is so much. The value of Kc for this reaction will be. It is based on stoichiometric calculations. So what is the reaction they have given? SO3 gives SO2 plus half O2. Okay. Equilibrium constant is SO2 into O2 raised to half divided by SO3 concentration. And that value given is 4.9 into 10 raised to minus 2. Correct? Is it 4.9? Yes, it is 4.9 into 10 raised to minus 2. Okay, fine. So here we have. On taking squares both the sides, what we get? We get SO2 the whole square into O2 square by 2 gets cancelled. SO3 the whole square is equal to, squaring this comes out to 24.01 into 10 raised to minus 4. Now Kc for the reaction. SO2 plus O2 gives 2SO3. So it is 2 here. What is Kc? Equal to SO3 concentration square upon SO2 concentration square O2. Correct? So it is how much given? It is nothing but same of this. Can you see here? Only it is reciprocal. Therefore, I can write 1 by 24.01 into 10 raised to minus 4. The answer comes out to 413. I'm sorry, 416. So let us see which is the correct option. Option C is the correct option. Yes. Next question. 4 species are listed below. HCO3 minus, H3O plus, HSO4 minus and HSO3F. The correct order of acidic strength. Yes, if you look here, it depends on the electronegativity. So this comes first. So I'll write HSO3. I'm sorry. H. So HSO3 Okay. HSO3F comes first. Then comes what? Then comes H3O plus. So strength, acidic strength I'm writing. Then comes HSO4 minus because it is a conjugate base of H2SO4. Then comes HCO3 minus because it is a conjugate base of H2CO3. Yes. So this is fourth one. H3O plus is second one. HSO4 minus is third one. And this is first one. So 4, second, third, first. First, third, second, fourth. So it is option C, which is the correct option. Correct? Option C is correct. Is that right? Yes. Next question. What is the next question? Okay. Here there is a slide. This is not the question number. Okay. Okay, fine. So the exothermic reaction is being given for ClF3. For ClF3 is represented by equation Cl2 plus 3F2 gives 2HClF3. Which of the following will increase the quantity of ClF3 in an equilibrium mixture of Cl2 and F2? That means where the product formation is more. Forward reaction have to be favored. When forward reaction will be favored? When you increase the concentration of both the reactants, first case. And since the reaction is exothermic, when you decrease the temperature, the reaction is favored in forward direction. Correct? So here H is minus 329 kilojoules, so it is exothermic. When you decrease the temperature, the reaction will be favored in forward direction. So this is what, according to Le-Chatelier's principle, lowering of the temperature or addition of F2 or Cl2 favors forward direction, hence the product formation of ClF3. So which is given here? The correct option is option A. It is option A. Okay. Next one. Match the following they have said. So let us match it out. QC is less than KC. Means what? It means reaction goes from left to right. It is less. It will, till equilibrium is reached, it will go from left to right. Correct? Second one, QC is more than KC. That means the reaction will go from right to left. It will come in backward direction. QC is equal to KC. No net reaction. Is that right? So which is the correct option? The correct option is for A. For A it is 2. For B it is 1. And for C it is 3. So correct option for A it is 2. B it is 1. C it is 3. So option D is the correct option. Option D is the correct option. Correct? Next question. How many moles of PCl5 must be added to 3-liter flask to obtain Cl2 concentration of 0.15 molarity? Okay, let us solve it out. So at equilibrium, if we speak at equilibrium, yes, the moles of Cl2 must be, according to our explanation, or yeah, according to our question, 0.15 into 3. That is nothing but 0.45. Okay. PCl5 dissociates how? PCl5 dissociates to give me PCl3 plus Cl2. So here if you see, it is 0.45, 0.45, and here it will be how much? X minus 0.45, how much you had taken. Correct? Since it is 3 divided 3 molecules divided by 3 I will do. Okay. This is equilibrium concentration. Now what is Kc? PCl3, total number of moles, 1, 2, 3 are there, into Cl2 divided by PCl5 concentration. Solve it out. 0.15 into 0.15 divided by X minus 0.45 divided by 3. When you solve it out, you will get the answer for X, and answer for X is 2.1 moles. It will come out to 2.1 moles. So which is the correct option here? Option B is the correct option. Option B is the correct option. Next question. In the following reaction, hypothetical reaction, A plus 3B gives 2C plus D. Initial moles of A are twice that of B. If at equilibrium moles of B and C are equal, percentage of B reacted is. Good question. So how do we understand it? Reaction is given A plus 3B gives 2C plus D, right? Okay. So this is 2A and this is A. This will be 0 initially. X, if it is degree of dissociation, it will be 2A minus X. This will be A minus 3X because here there is 3. This will be 2 into X and this will be X, correct? So according to the condition given, how much will be remaining? A minus 3X is equal to 2X. This is the condition. B and C are same. Yes, this is the condition. Therefore, X will be equal to what? X will be equal to A by 5. A by 5. So minus 3X goes there. 5X it becomes. X will be A by 5. Percentage of B reacted is how much? It is 3X by A into 100. So 3 into 3 by A into X value is what? A by 5 gets cancelled into 100. So 3 by 5 into 100 comes out to what much percentage? 60%. So what is the correct option? The correct option is 60%. Which of the following can act both as Bronsted acid and Bronsted base? Bronsted acid means what? Which gives proton. Which gives proton donor. Proton donor. Bronsted base means proton acceptor. Okay, so Na2CO3. No, it does not act. OH minus. It will only take proton. It will also not act. HCO3 minus. HCO3 minus can lose one proton and form CO3 minus 2 plus H plus. So it will lose one proton. Or HCO3 minus can gain one proton and form H2CO3. So it is correct option. It acts as both Bronsted acid as well as Bronsted base. What about NH3? NH3, it can only gain proton and form NH4 plus. If they would have given NH2 minus, then we would have thought of. Correct? Then moving to the last question of this topic, match the following columns. N2 plus 3H2 gives 2NH3. Temperature is 300 degrees Celsius. PCl5 is what? Here it is PCl5 gives PCl3 plus Cl2. Then carbon plus H2O gives carbon plus H2O gives me what? It is in, okay, it is here CO plus H2. It is printed here CO plus H2. And then option D, it is given like this. Okay, which is the correct matching here? Match the following. Okay, the question is halfly printed here. Let us match it out and see. Fine. Okay, so first one, N2 plus, it is option A, N2 plus 3H2 gives 2NH3. It is for what? If you see here, Kp is equal to Kc RT delta N. Yes, RT delta N. Okay, I will take it here. I will take it freshly here. For option A, Kp is equal to Kc RT delta N. Correct? Kp by Kc will be equal to what? It will be equal to RT delta N. And what is delta N here for the reaction? N2 plus 3H2 gives 2NH3. It is negative. If it is negative, Kp will be less than Kc. So option A is Kp less than Kc. Okay. Option B. If you see for option B, what is the option B having there? It is having PCl5 gives PCl3 plus Cl2. What is delta N here? 2, 2 minus 1, that is 1. So delta N is positive. Okay. Third option is what? C plus H2O gives me CO plus H2. Okay. This is solid. And D option, I will write it here only. Then we'll discuss CH3COH plus C2H5OH gives me CH3COO C2H5 plus H2O. Okay. So what is the discussion here is, so if you look at this option B, okay, delta N is positive means what? Delta N is more than 0. So for option B, delta N is more than 0. It is more than 0. Correct? Okay. Then for option C, C2, C plus H2O is how much delta N? Rest all are gases. So delta N is 1, 2. 2 minus 1, that is equal to 1. Correct? Delta N is 1. So for option C, delta N is equal to 1. For option D, as the reaction is not containing any, all are liquid in state, right? As the reaction is not containing in any component, Kp is not defined. So for D, Kp is not defined. Okay. Kp is not defined. So Kp is less than Kc. So let us match it here. For option A, Kp is less than Kc. Okay. So option A, it is second one. Okay. For option B, what is it is? Kp PCl5. What we have seen for option B? For option B, we have seen delta N is greater than 0. Delta N is what? Greater than 0. Okay. So for option B, delta N is greater than 0. So it is first one. For C, it is fourth one. So let me match it now. So let us match it. For option A, it is second one. For option B, it is first one. For option C, it is N equal to this. And D, Kp is not defined. So let me write here. Option A, it is second one. Option B, it is first one. Option C, it is third one. And option D, it is fourth. Sorry, option C is fourth one. Option C is fourth one. And option D is third one. Kp is not defined. This is the correct match. Yes. The options are not given here, but this is the correct match. Is that right? So we have discussed ample number of questions on equilibrium. Hope you have understood the concepts very well. Please practice all the questions. Yes. So I've done all the questions. Thank you.